Okay, so here we have a pretty short chapter, but it's on the geometric mean. And the geometric mean is a really kind of an interesting, it's kind of an interesting concept. It's this idea we're going to learn about in here and how we can find it. So, you're going to read through here, and I'll point out where the key important things are. Here we have a right triangle, and you see an altitude coming through the right triangle to the from the right angle to the hypotenuse here. So then what happens is this altitude is splitting that hypotenuse into two parts, and that's an important thing. We're going to figure out what that exactly means and the value of it here in a little bit. And at the end of this lesson, you're going to come back and use what we just talked about. You're going to use it to solve this problem. So anyway, you're drawing an altitude again from here to the opposite side. Remember how you can construct a perpendicular through any point? Is the idea first, set your needle here with the compass, create an arc. From the compass, you'll find 2 points that are equidistant from there. Create arcs from those 2 points, and then draw a line through them, and you will have hit the vertex here, this where the right angle is, and you'll have a perpendicular that goes through it. So again, it starts by placing a needle on C, creating the arcs with the compass, then taking the 2 intersection points and constructing the perpendicular bisector, like we've learned before. It talks about naming all right triangles. Realize that once you've done that, this perpendicular will create 2 separate triangles, a smaller one here and a smaller one there. And then, of course, you have the large triangle here. That's what it's referring to. It says trace each of the triangles on separate pieces of paper, and they want you to actually cut them out, all 3 of them, after you've traced them, and you should have them like in the same orientation. So in other words, you might put the short side here, the right angle going out to the long side, and the hypotenuse coming back. And what you want to do is you want to do that for all 3 of them, and it will help you to think about this problem and answer this problem. So you should have, when you're done, you'll have pasted 3 right triangles here, the large original one, then 2 smaller ones, one that represents the right side and one that represents the left side of the right triangle that you split. And you're going to name them, and you're going to mark down that they're proportional. And now we're going to get into this thing of the geometric mean. So the geometric mean of 2 positive numbers, a and b, is the positive number x, such that a over x equals x over b. So in essence, when we want to solve equivalent ratios, it's really helpful that you have to know 3 of the 4 parts. And by finding the geometric mean, you can just know 2 parts and plug in, or you can just know 1 part rather. If you can find the geometric mean, it substitutes for 2 parts. Okay, so again, like in this original problem, we're going to go back up to here where they were. You know what? Let's scroll up here a little faster. Actually, let me do it this way. Okay, so you have 3 parts here, right? You have something I can measure, right? Another thing I can measure, and then a part I can't measure. Here, this is going to be difficult to measure, this hypotenuse, but it could be done. In essence, if I need to solve for an unknown side, it would be really helpful if I could put it into a ratio. So if I could put this into a ratio here, I could solve for the unknown side. This would represent 1 part that I know, or this could represent 1 part that I know. And then what happens is the geometric mean represents 2 parts, which we'll get into here. And then the missing part is if you have 4 parts and you can find 3 of them, you're going to be able to solve for the 4th using basic algebra. So here's how it works. There's 2 basic theorems. The first is the right altitude hypotenuse theorem, and basically the idea is that from the altitude, which comes, this only works in a right triangle, by the way, which should be obvious. I don't know why they call it the right triangle altitude hypotenuse theorem, because if it's got the word hypotenuse, it's got to be a right triangle, right? But the idea is the altitude hypotenuse theorem says you're going to start at the right triangle. You're going to draw an altitude that ends on the hypotenuse. And then basically the measure of this altitude is going to turn out to be the geometric mean of these two parts, AD and DB. So in that original problem going across the ravine, basically, oh, sorry, let me get this again. So basically in the ravine, what you had is you had, you had this section that you could measure, and we could determine what the altitude was. And once you've done that, you know that you can set a ratio, and it's going to be like this side, or let's say the mean divided by this side is equal to this side divided by the mean. Okay, that's how that'll work. And so if I were writing that into, let's see if I can put some text in here real quick. Where's my text tool? Oh, I'm sorry. I should pause this until I find it. See if I can do this here. I don't know. Okay, well, maybe you can read what I'm writing, but basically, I've got AC or CA, which I can put over, I'm sorry, we're going to do AD because we're doing the right altitude hypotenuse. So AD, well, let me do it this way. I can put X over AD, this keyboard, is equal to dB over X. So as long as I know that altitude, as long as I know the altitude and the distance AD, I can plug those three parts in, and then I can simply solve for dB for this unknown dB right here, that distance. That's what that ratio is going to look like, okay? Let me delete that, okay? And so now the leg theorem, is a little different, but basically it just says that if you draw an altitude, then each leg of the right triangle is the geometric mean of the hypotenuse and the segment of the hypotenuse adjacent to the leg. So let's think about what that means. This side, AC, is going to be the geometric mean of two values, AB and AD. So this is the mean of AB and AD. Therefore, if I know AC and I know AD, I can write a ratio. If I didn't know, if I want to, I could do the other way too. CB is the mean of BD and BA. Okay, so let's do this geometric mean like as if you were in that original problem, and it's going to look like this. CA is going to be the mean, so that's not my text tool, but it's going to have to work because I guess I can do this thing, and then I can just type. Okay, sorry about that. All right, so I can say that AD divided by CA is going to be equal to, I see I should put that, you can put it either way. And what I like doing is I like putting the unknown side on the top. So, okay, ACA. So notice the geometric mean goes on one side, it goes on the numerator, on the other side it goes on the denominator. And the other two parts using the leg theorem is that the one leg, that's in this case going to be CA, is the mean, and then what it's the mean of is the side next, the segment next to the leg, and the whole hypotenuse. And since the whole hypotenuse is the part we didn't know, you could use that to solve the problem like this. That's how you'd set it up, okay? All right, now you're going to use that again. Here you have this altitude, so you would go something like this. You would say x over 4 is equal to 9 over x. Or the other way around, you could go x over 9 is equal to 4 over x, and you'd solve it. Again, you go x over 8 is equal to 8 over 4 and solve it. And that's the idea there. And here you have x over 20 is equal to 24 over x, and then solve. And here you have x over 2 is equal to 8 over x, right? That's how those are done. And to solve x, y, and z. Okay, so now what you have is you have x being the geometric mean. We'll start by solving that one and using these two parts. So I have 10 over x is equal to x over 5. And you solve that. Once you know x, then you can do, let's see, well, you can do x, let's see, 5 over x is equal to, whatever that value is equal to x over z, and solve that. Or the other way around, z over x is equal to x over 5. Of course, you're not going to be using x, you'll know it, and then you'll know z, and then if you want, you can just use regular old Pythagorean theorem, z, 15, and y to solve for that. That can be done then. And then you're going to go back and solve the geometric mean using the technique that we've talked about. Okay? Okay.